Phasor diagram for AC through a capacitor. We have seen when an alternating voltage is connected across a capacitor, the current is found to be leading the voltage by a phase angle pi by 2. That means for the capacitor case, if I take the voltage as V equal to Vm sin omega t, then the instantaneous current through the capacitor will be I equal to Im sin omega t plus pi by 2. This is the case. Now, to draw the Phasor diagram based on this, we have to consider the waveform first for the case. And that waveform I can consider here as this is voltage and current that we have. So voltage, let me take that voltage to be this much, Vm, and the same Vm over here, and pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. Those are omega t around this way. Now, when I draw the waveform for the AC voltage, it must be of the form. It goes like this, the waveform. And it goes like this. Okay? So this is the instantaneous voltage, that is Vm sin omega t. At the same time, the current leads the voltage by pi by 2. So when it leads the voltage by pi by 2, when the voltage is 0, the current will be maximum. Means when omega t is 0, V is 0. When omega t is 0, I equal to Im on the positive side. So if I take this as Im, okay, this much is Im, then the current starts from here and follows this path. Okay? And it goes like this. Alright? This is how the current is going. So the current is leading the voltage by a phase angle pi by 2. Now based on this, I have to draw the Phasor diagram. So to draw the Phasor diagram, let us consider the 4 quadrants here. I am taking the 4 quadrants onto this side. Okay. 4 quadrants. And let us consider the omega t somewhere here, very close to pi by 2. Then, if I draw the parallel line with the y-axis, the line will be meeting the voltage at this particular point. So, the voltage must come here. This much is the voltage. Okay. This much is the voltage. So, this is the voltage corresponding to that. Then I'll be measuring the peak value. This is the peak value. I'll keep it over here and I draw this one. And what I'm getting is the value somewhere here. This is Vm, so that this is omega t. So I get this as V equal to Vm sin omega t over here. Okay? Then at the same time the current is this much only at that point, and that too on the positive side here. Okay? But what's the problem there? When the voltage is going to be maximum, the current is going to be 0. So it has to be onto this side, and therefore I measure this over here. And this is the case coming, and we want this current to be leading the voltage by pi by 2, and you can see this is the peak value of current here, and I make it over here and go. Okay? So what I am getting is the current Im is here, and the angle between voltage and current is found to be, you see this one? Okay? And the voltage and current is found to be equal to 90 degree here. So the current I equal to, I is this much, and this current I, this much current, that is equal to what? Im sin omega t plus pi by 2. Omega t plus pi by 2 is current. Okay? So voltage is in the first quadrant, and current is now leading that voltage by a phase angle of pi by 2 in the case of a pure capacitor. So this is the phasor diagram for the AC flowing through a capacitor.